All right, great. Thank you.
Can you? Okay. I don't think I'll be quite as funny. So, all right. So yeah, I'm Michael Drabelbis. I work at Machine Zone. I do data ingestion. Yeah, basically, I'm going to talk about what we use Goblin for and kind of the road to choosing it and some of the customizations and stuff that we've done. It. Little marketing information here. Machine Zone is a mobile gaming company. We have kind of built a marketing, what we call performance marketing platform around leveraging a lot of different ad networks to buy a bunch of ads and get ROI on top of it. We have what we call the Cognate division, which is the business unit that handles all of the marketing data and handles all of the internal game marketing data as well as for our external clients because we turn this into a product. So kind of little overview of what we're going to talk about. Kind of the requirements that we had and some of the problems we were encountering, how and why we chose Goblin, then through some of the customizations and how we deploy Goblin and how we use it. And then we'll go with some questions at the end if there's any time. So yeah, so for kind of an initial thing, we ingest data from over 300 different ad networks. We work with a lot of different companies, and they have a lot of different schemas and a lot of different, I don't know, the ad performance data, it all looks very similar, but all these companies have different representations of basically the same data. So we have to take it all in, do some normalization on it, and put it into a reporting mechanism. So we needed to support ingesting data from REST API and email through like kind of Gmail ingestion, S3, and we also do streaming ingestion for Clickstream data, mostly for cold storage for events from Clickstream and also post-install events. And basically, yeah, so we need to take all this data from all these different sources, normalize it, put it into kind of a reporting schema that made sense. We needed to support partial data sets, so we didn't always get like a full refresh for a particular partition. It could be like partial, so we needed to support that. I'll talk a little bit about that later. And we needed something that scaled horizontally because as the business grew, we needed to handle that. So why did we choose Goblin? So talk a little bit about kind of history there. We were a little bit familiar with Kamu, which is kind of the predecessor to Goblin. Used Kafka to HDFS, pretty stable framework for doing so. I'd used it before, so pretty familiar with that. Had some stream and batch both as a requirement there, so that was useful. For us, it was a minimal learning curve. I know you said there was a steep one, but since we had used Kamu before, it wasn't too difficult to get put together for us, and it was configuration driven, so we didn't have to spend too much engineering resource to build a lot of things. Some of the bad stuff, I don't know, bad is not really the word I should have used there, but there's no higher order API, so we use it primarily for data ingestion, just pulling in data, taking it from one source and writing it to another. If you want to do like more complex transformations or more complex applications, you might want to use something like Flink, Beam, or Spark. They have a higher order API for interacting with data sets more so than Goblin does. There wasn't really much community support when we started working with Goblin, which was back in April of 2016, and there was no nice GUI to like see where jobs were going and that sort of stuff. So that was some of the negative points with Goblin, but it fit the bill, so we ended up going forward with it. Talk a little bit about the kind of initial thing. I don't know how much people know about how it works, but I'll talk a little bit about this and then go like what customizations we had on top of that. So everything like comes from the state. The state is like all the properties that a job runs with. You use the state to generate all the work units that are sent to for task execution, and basically the source takes the state to generate work units. Those work units are then run on, if you're using MapReduce, a particular map task. That map task creates an extractor which runs the extraction to pull the data from the source generates an iterator, which is then passed to the converters, which there can be one or many converters. And then that is sent to the quality checker, which does some checks around there's a couple different types of quality checking. You can do row type quality checking or task level quality checking. We have a couple of custom ones that we use. And then if it passes the quality checks, it goes to the partitioner writer, which will split the data up and write it to the destination. It's usually a temporary location. And then the publisher will take that temporary location, make it final. In HDFS, that's the final thing. So that's normally what we kind of publish data to. So we started using Goblin at 0.6 a long time ago, year and a half. And took us only about 3 months to go to production. There's only 3 people working on it. So it was pretty easy for us to take the initial thing and kind of work it to a productive environment. We didn't really change any of the core code. We just pulled in the libraries and the runtime environment and added our own customizations on top. We've been upgrading it all the way to 0.9. We stopped at that point because 0.9 was working pretty well for us. So we might upgrade later, but that's what we're currently working with. We replaced an existing homegrown ingestion framework. It wasn't very good. We had this ingestion for Facebook that never really worked. Got it to under an hour, which was pretty good. And we have our own DSP we were ingesting data from. Used to take 5 hours, got it down to 20 minutes. This is just because the HDFS splitting of files was pretty good, and we didn't have that in use before. So how would we deploy it? Goblin, they talked about, they have kind of standalone mode and MapReduce. We use both local mode for developing new features and integrations, and then we publish to our Hadoop cluster to do the MapReduce jobs. Local mode's pretty nice for the devs to do the new testing and new integrations. We use Jenkins to deploy everything to the runtime jars to the Hadoop cluster, and then we use Azkaban for doing all of the job scheduling. We manage about 225 different ingestion jobs with Goblin, and we separate the jars with the job files. You can package them all in one for Azkaban, but that's an Azkaban talk. Basically, we separate them so that we can deploy them independently because the job files change more often than the application jar does. So yeah, some of the customizations we made, since we started before, there was a lot of the support. Some of these things exist now in the core libraries that didn't exist when we were there. S3 file support, email file support. We were doing CSV extraction, so we needed header validation on the email files because people were sending us files with columns in different orders, so we had to implement that. The REST API extractor for Goblin is pretty good if you're just doing a single pull of data from a thing. We didn't have anything for handling async polling or pagination, so if you had a job that took a long time and then you had to pull an endpoint, we had to implement that ourselves. So that's something we probably could contribute back to the community, I guess. Yeah, one of the biggest changes or features that we implemented was a rule-based converter. It basically takes an input record and any number of custom rules. They're defined by a rule set. Those rules are then read in, parsed, and then applied on the input record to populate the output record. Some of those examples numeric cast or timestamp, date, math, substring. These are all things that are required when you're dealing with so many different types of data sources. Normalizing them required us to have a pretty flexible, so that's why we implemented this. For quality checking, we implemented a required fields policy, which basically checks to make sure that there are certain fields in the destination records. It's a row-level policy. So yeah, that's some other things we did. For the partitioning, Goblin has a time-based partitioner, which had the ability to do schema columns before the time partition. We wanted to have both before and after time partitioning, so we had to implement a custom one to do that. There was no support for ORC or Parquet when we started, so we wrote our own. And we use the Parquet one the most. It has the most support in for our downstream applications. So we didn't end up using ORC, but yeah, that's kind of, I don't know how well people can read this, but basically this is just a kind of high-level overview of all the different data sources that we use. All of the entire box represents Goblin. This reads the data, goes through the rules engine converter, which loads the transformation rules. We have one per data source per network integration. So for example, Facebook spend has its own transformation rules. Facebook campaign data has its own transformation rules. These are all written to what we call the unmerged data set. So compaction was a big problem for us because we were using so many different types of data sources, and I'll talk a little bit about that in this slide. So some of the learnings we had, job properties, templating was not initially implemented. It came in 0.7, I believe. So that helped us a lot. Once we had so many job files that templates really helped us manage the properties well. One thing we really didn't like about Goblin was that when you initially start a job on the Hadoop cluster, on the driver, it materializes all of the work unit states in memory. And we had one job that kept blowing out the memory. That was a big problem for us. So we had to figure out some different ways to chunk it out. We enabled metrics and monitoring in Goblin, but it was just way too much noise, not really anything useful for us, so we had to disable that. And then a note about compaction. It works great if you're using Hive tables with single primary keys, or if you're JSON key ordering matters, if you're writing out to JSON. So we had to write our own custom compaction application. This is because we had a single add performance table that was pulling in with multiple different primary keys from all the different data sources. So we had to write an application to basically support partial merges for that. These are some stats around what we're using currently with Goblin. We ingest about 125 million records per day for just spend data. We manage over 500,000 ad campaigns, 5 million ad groups, 20 million ads. Our biggest ad job these are all batch. Streaming is a whole different set of numbers, but in the batch, 7 million records for ads is our biggest one. And currently we're running 250 active ad integrations. I know I said 300 before, but we have sort of a revolving door of ad networks because some are good, some are bad. We have to kind of cull the herd. And yeah, so that's basically what we do with Goblin. Any questions?
You mentioned that there are no higher level APIs. So where did all the rules stuff, how did you manage? Did you write custom code for everything, or?
Yeah, so we wrote, basically there's a converter interface. And so we wrote a custom converter that it basically reads a rule set based on the known data type that it's working on, and parses that into basically a set of functions that can be applied on the input record. And that's basically how it works.
Other questions?
Sorry, so I'm a bit rusty in this space, but I used to work for a company called SnapLogic, and some of what you said reminds me of stuff that SnapLogic does. Would you mind contrasting what you guys do with what SnapLogic does?
I'm not familiar exactly with SnapLogic, but if you're talking specifically about what we do with the performance data, is that what you're referring to?
Actually, I think that's a better question. Again, I'm the dumbest person here, so maybe you can remind me of what exactly the value proposition is from you guys?
Right. So when you spend money on ads, right? You can pull that information. Like, okay, I don't know how much time you have, but basically what we try to do is we spend money on advertising, and we gather a lot of data points about where that money is spent and how that money gets turned around and turns into installs, which then turn into, or clicks, which turn into installs, which turn into revenue generating, the funnel, that sort of stuff. All of that happens after the point of ingestion, and sort of the purpose of this talk is to talk about the ingestion part. So, yeah, sure.
All right, I had one question. You had something on your slide on emails. So are you actually ingesting emails and then processing them?
Yeah, so we have an email account that is specifically for network ingestion from external parties. We basically, like, this job runs, it scans the unread emails, downloads them, and then generates work units per email that then get processed as a file, simple file ingestion. We also had to implement gzip extraction. That wasn't something in Goblin. I think it is now, but yeah.
Could you please contribute that back? Just from a context perspective, there's a lot of data sharing that happens over email, specifically keys. Like if anyone has set up a data integration where you're encrypting data, and then you have to set up an out-of-band way of shipping keys, that typically goes over email. So it's actually pretty cool if you can use the same technology to ingest both encrypted data as well as keep your keys in sync using email. So that's like pretty cool thing that you guys have done. Next up is LinkedIn. I think Eric and Anthony are going to be talking about what they've been doing. Thanks, Michael.